Yeah, it sounded like the big bad wolf was outside. Okay, so suppose you have two trigonometric, complex numbers in a trigonometric form. Our first one is R1 times cosine of theta sub 1 plus I sine of theta sub 1, which just means that it has a certain radius and it has a certain theta. True or false, we learned how to find R and theta yesterday. A for the day, what is the formula to find R? Good. Square root of a squared plus b squared. And what formula do we use to find theta? Tangent of theta is equal to b divided by a, and we solve that according to where it's plotted. You do that, you're good to go. So we've got two trigonometric numbers here. Suppose that you want to multiply them. You take z1 times z sub 2. What you do to the r values is you multiply them. Is that easy enough? And then the theta values, you add them. So theta sub 1 plus theta sub 2. So if you have two complex numbers that are in trigonometric form and you want to multiply them, multiply the r's and add the thetas. Let's practice right away. Please look at the first, or this example number 4. It says given z sub 1 is 2 cosine of pi over 4 plus I sine of pi over 4, and z sub 2 is 5 cosine of pi over 3, I sine of pi over 3. Find z1, z2. So if I multiply them together, what is the new r value going to be? 10. Times the cosine of pi over 4, pi over 3. In order to do pi over 4 and pi over 3, add them together, I have to find? Very good. 3 pi over 12 and 4 pi over 12. That's the way I roll. So if you add those together, what do you get? 7 pi over 12. So it's 10 cosine of 7 pi over 12 plus I sine of 7 pi over 12. That's it. There's no twist. Like we're gonna take them to powers in a second, but it's super cool. It's no big deal. Trust me. Trust me. That's. But when you're multiplying, that's all you got to do. Here, watch what will happen here. We'll divide them now. Well, because division is cool. Like my daughter Temley, she's just learning division. She's super excited about it. Z sub 1 divided by Z sub 2. Anybody want to guess? What do you think I do with the R values? Hey, look at that. R sub 1 divided by R sub 2. What do you think I do with the theta values? Amen. Theta sub 1 minus theta sub 2. Yeah, and when you like write this down, like if other people look at your homework, they're like, "Wow, you must be really smart." And when you look at it, you're like, "It's really not that big of a deal. You just multiply the r's and add the thetas. Like that's all you do." That's right. You couldn't. I like it. I like it. All right. So Z sub 1 divided by Z sub 2. What's the new R value going to be? 2/5 times the cosine of, we had 3 pi over 12 and we had 4 pi over 12. Subtract them and you get negative pi over 12. plus I sine of negative pi over 12. Uh-oh, what's wrong with that?
Negative.
Can't have a negative angle. Do you remember from our last unit what happens to the cosine of a negative angle? It just disappears. Isn't that awesome? It's like Christmas. Cosine of pi over 12. And then what happens to sine of a negative angle? The negative draws out front, and when I say out front, in front of the sine, so it'll be minus I sine of pi over 12. So far, a trigonometric form of complex numbers is not so bad, is it? Nope. The last thing we're going to do with trigonometric form of complex numbers, and I will say that I think that this next piece would be considered the most challenging part of your test. If you can do this next part, you're ready to get an A. Let's go. DeMoivre's theorem. Let Z equal R times cosine of theta plus I sine of theta. You don't like his name? Fine, we're gonna we're gonna go L stay there. The L stay theorem. Is it all of a sudden now great? We're just gonna name them after our. We're going T-palm. The T-palm theorem. Okay, there you go. Well, you don't want your name up there?
No, I don't want it.
Okay. Now, we'll see if you can figure this out. If we're going to take that complex number, and now instead of multiplying or dividing, we're going to raise it to a power. Anybody want to guess what I do to the R value? I raise it to the power. Anybody want to guess what I do to theta? So I want you to think about this, okay? R to the nth, that's like R times R times R times R times R, right? And then, so what would you do to the thetas? You would add the thetas, right? So how many thetas am I adding up? N thetas. So if you're adding up n thetas, that's the same as taking theta and multiplying it by n. So cosine of n theta. You just take it, multiply it by n. Okay, we got 3 of these examples. You lean in, you focus, and hopefully you'll be okay and you'll get it. We'll all be good. All right? It's not easy, but be patient. This will be the hardest part of your test. It says find 1/2 plus 1/2 I raised to the 10th power. Do we all agree that multiplying that out 10 times would take a lot of time? So let's not do that. Let's use DeMoivre's theorem instead. It says first put it into trigonometric form and then just do this thing and you'll be fine. So let's first convert this into trigonometric form. In order to do that, we need to find R. We need to find theta. How do I find R? Good. Square root of a squared plus b squared. What is 1/2 squared? A fourth. And 1/2 squared is a fourth. Fourth plus a fourth is? 2/4, which is a half. Good, good. So I got the square root of a half, right? Now, before you go crazy, folks, with this, I'm going to write this square root of a half. Isn't that the same thing as 1/2 raised to the 1/2 power? I'm just going to leave it like that for a second, okay? All right? Before I go about trying to rationalize the denominator and all that stuff, I'm just going to leave it like that for a little bit. You okay with that? All right. So in order to find theta, what is the formula I use? Tangent theta is b over a. So I go tangent of theta is equal to, what is b divided by a? 1. And so we get tangent theta is 1. if you inverse tangent of 1, anybody know? 45 degrees. Which quadrant is this in? First quadrant. So everybody agree we're at 45 degrees? Great. I got to convert that to radians. So I've got pi over 4. So theta is pi over 4. You've done great work so far. Way to go. So here's what we've said so far. We've said we have r, which is 1/2 raised to the 1/2 power, times the cosine of pi over 4 plus I sine of pi over 4. So we turn that into that. We now want to take it to what power? The 10th power. So I'm going to take this guy and I'm going to raise it to the 10th power. I know it looks ridiculous, but just think of how bad it would have been to multiply this out 10 times. And we're actually almost done with it. If I have a power to a power, what do? So everybody agree this turns out to be 1/2 to the 5th? See why I wrote it like that now instead of writing it with the square root? So I got 1/2 to the 5th. Times, what do I do to the angles? Multiply it by 10. And I get cosine of 10 pi over 4. What's 10 pi over 4? 5 pi over 2. We're getting close to what your final answer is going to look like. This isn't too bad of a number. It's not too ridiculous. What's 1 to the 5th? 1. What's 2 to the 5th? 32. Here's where sometimes people fight me. Please don't fight me on this one, okay? I need to just sidebar here for a second. We got 5 pi over 2. Just need to help you see the visual of what's going on. Everybody agree that that's 1 pi over 2? 2 pi over 2? 3 pi over 2? 4 pi over 2? 5 pi over 2. So that's the same location as just pi over 2, right? So if you get a number that's bigger than 360 degrees or bigger than 2 pi, just take that 5 pi over 2 and subtract off 2 pi or 4 pi over 2, and you can see you're going to come up with that. We're just finding the coterminal angle, if you remember when we did coterminal angles like multiple times around. So we'll do that a couple times. When I go to that, I'll just be subtracting something off to find the angle that's between 0 and 360. That's what we want, the angle that's between 0 and 2 pi. We okay with that? All right, so we go back to our deal. And we got, this turns out to be the cosine of pi over 2 plus I sine of pi over 2. This is what you call trigonometric form. On your test and on your worksheet, you're going to be asked to list it, to put it in trigonometric form, and then also place it into what we call standard complex form. So we're going to put it back into a normal complex number. And it may sound bad, but it's the most fun part of the deal. It's pretty cool. Pi over 2, I'm up here. It's cosine the x or the y. The x, what's the x value up here? 0, right? 0, 1. Everybody agree 0? So this is 0 plus sine. Sine is the x value or the y value? Y value. What's the y value up here? 1 times I is I. So this whole thing just ends up being 1/32 times I, or I over 32. This is what you call complex form. So you have 2 results. So if you were to take this and multiply that out 10 times, what would you get? You actually get I over 32. Now, some of you are doubters, and it's okay. It's okay to doubt things and be skeptical. You're like, I think I actually could have multiplied that out faster. Okay, try it now. Like, do you understand that if there's a 10 here, it's no different than having 100. Our process stays the same, doesn't it? But yet, if you were to multiply that out 100 times, well, that would take you a week. So it really does save you a ton of time in those pieces. All right, good. Good job. Way to hang in there. It's a tough lesson. You guys are doing good. You must be really smart. Let's try this one. Oh, we're going to get to the 100th power. That's so fun. Here we go. Take 1 plus I roots of 3 to the 20th power. I start by putting it into trigonometric form. I need R, and what else do I need? Theta. How do I find R? What is A squared? What's B squared? 1 plus 3 is? Square root is? Good. So R is dos, which is Spanish for 2. We good? How do I find theta? Tangent of theta is? B over A. What's B over A? Root of 3. Root of 3. Which quadrant is that in? First quadrant. Anybody remember if you inverse tangent root of 3, what you get? 60. Anybody see that? Nobody knows the reference? 60. I'll have to show you at the end of class. It's going to be so fun. All right. Okay, so 60 degrees, which in radians is? Pi over 3. Whoa, look at how quickly we're coming up with trigonometric form. We've got 2 times the cosine of pi over 3 plus I sine of pi over 3. Sweet. I want to take it to what power? 20th power. What do I do with the dos? To the 20th power. What do I do with the angle? Multiply it by 20, I get 20 pi over 3. Everybody agree, like 2 to the 20th, like that's kind of a ridiculous number. Yeah, it's pretty big. So we're just going to write 2 to the 20th. Oh boy, 20 pi over 3, is that more than once around?
Yeah.
Definitely. So we're going to subtract off once around. Once around is how much? 360, or in radians it's 2 pi, right? Once around is 2 pi. Everybody good? Once around is 2 pi, or otherwise known as 6 pi over 3. Everybody see why I chose 6 pi over 3? So subtract off 6 pi over 3, what do you get? 14 pi over 3. You agree 14 pi over 3 is still more than once around? Subtract it again and you get 8 pi over 3. Everybody agree 8 pi over 3 is still more than once around? Subtract it off again and you get 2 pi over 3. That's trigonometric form. Now we're going to place it into standard complex form. So I need an exact value for cosine of 2 pi over 3. 2 pi over 3 is how many degrees? Good, 120. It's going to leave me with a 60-degree angle over here. What's this coordinate right there? So cosine is the x value or the y value? X value. So we get 2 to the 20th times negative 1/2 plus I roots of 3 over 2. So we're almost there. When we distribute the 2 to the 20th, we get negative 2 to the 20th over 2 plus 2 to the 20th I roots of 3 over 2. Hey, 2 to the 20th over 2, that's going to make 2 to the, this is 2 to the 1, 2 to the 19th. So we get negative 2 to the 19th plus I2 to the 19th roots of 3. And that's complex form. Good work. You hanging in there? Last one. Find I, or 1 minus I, to the 100th power. Ugh. There's no way I can multiply that 100 times. But I am going to find R and theta and put it into trig form. R is going to be the square root of what plus what? 1 plus 1. So I get the square root of 2. Or I could write that square root of 2 as 2 to the 1/2 power, right? How do I find theta? Tangent of theta is equal to b divided by a. So that ends up being tangent theta is equal to negative 1. Uh-oh, it's negative. Which quadrants? 2 and 4. Which quadrant is that in? That's 4th quadrant, right?
Oh, yeah.
So 4th quadrant, if I inverse 1 on my calculator, what do you get for tangent? 45? 45 degrees. So what's that angle going to be down there? 315. Turn it into radians. 7 pi over 4. So what that means is that my trigonometric form is 2 to the 1/2 power times the cosine of 7 pi over 4 plus I sine of 7 pi over 4. Now the whole goal is to take that thing and raise it to what power? 100? Are you nuts? Fortunately, we're really smart. 2 to the 1/2 to the 100th is 2 to the 50th. What do we do to the angles? Multiplying by 100, I get 700 pi over 4. Would everybody agree that 700 pi over 4 is definitely more than once around? Wouldn't that be a pain in the butt to like subtract off 8 pi over 4 over and over and over again? Let's just like try to divide it. What's 700 pi divided by 4? 175? So I get 2 to the 50th times the cosine of 175 pi plus I sine of 175 pi. That still sounds like a lot, but it's really quite simple, folks. 175 pi, is that an odd number of pi's or even number of pi's? Odd. Where does odd number of pi's leave you? Let's see. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Everybody agree odd number of pi's leave you over there? So it's the same as pi. 2 to the 50th times the cosine of pi plus I sine of pi. That is trigonometric form. Let's take it and turn it into complex form. We're over here. Is cosine the x value or the y value? X. What's the x value over here? Negative 1. What's the y value? 0. Sweet. Zero times I will give me a 0. Good job, everybody.